students, and congratulations of your grand success of your class 10 board exam. And you have decided to study science, and which is a turning point of your life. The direction of your life is determined by your choice, not by your circumstances. Your actions are not just a number, but a vector of influence pointing towards the direction you want to make. So dear student, you must have some determination and confidence over your work. So wish you all the best of your future prospect. So with this, here I am going to explain one of the vital concepts of your class 11 physics, which can be great help to you with important point of the vector chapter, scalar and vector. And that is the triangle law vector addition. How we can add the vectors using important concept law property, that is the triangle law. Okay? The triangle law vector addition of two vectors. And the important statement is that when the two vectors are represented by the two sides of the triangle taken in same order, then the resultant vector is represented by third side of the triangle taken in opposite order. Here is a vector A, and a vector has two parts. One is the head, the arrow point, arrow mark, and this part is known as tail. Let us connect another vector B, and this is known as the terminal vector. Vector A is known as the initial vector. You see here, the tail of the terminal vector B is connected with the head of the initial vector A, and this is called the vector in the same order. When the tail of second vector is connected to the head of the first vector, initial vector, we say the vector in the same order. There is another vector is connected R. Okay, and here you see the tail of the vector R is connected to the tail of the initial vector A, and the head of the vector R is connected with the head of the terminal vector B. So we say the vector R in the opposite order. So, and here, and if the three vectors are represented by the three sides of triangle, and out of them two vectors are in the same order, then the vector which in the opposite order is the resultant vector. We have to find out. So how to determine the resultant vector when the two vectors are represented by the two sides of triangle? It is one of the important concepts which is most applicable in solving various problems in physics. I hope I must be thankful for your patience and eagerness and toward the class. Right? So here analytical method of triangle law vector addition. If A and B are two vectors represented by two sides of a triangle inclined at an angle theta, then its resultant vector R represented by the third side of triangle taken in opposite order, which is given by the magnitude of vector R is equal to square root of A square plus B square plus 2AB cos theta. Okay, and the direction of the resultant vector tan beta is equal to B sin theta divided by A plus B cos theta. Here we are going to explain vividly, lucidly how the magnitude of the resultant vector and direction of the resultant vector. So here is a vector, one of the vector. Here another vector is connected in the same order. Here is the vector A, and here is the vector B, and we have to connect another vector, that is R. And R is connected in opposite order. So R is the resultant vector. And you see the two vectors act at an angle theta. Okay. And let the name of the triangle is creating a triangle structure, right? So let me give the name of the triangle O P Q triangle. And you see there is another angle, that is beta, which is the direction of the resultant vector. Okay. see once again, see, use vector A, another vector, and three vectors, the triangles are connected at the three sides of triangle. Name of the triangle OPQ. Here one construction just you do. Let us consider two vector. Okay, vector A represented by the side OP, another vector PQ which is B, making an angle theta with each other, and here the OP side has been extended up to M, and here beta is the direction of the resultant vector. And let us draw a perpendicular from the point Q, QM on the produced extended side OP. Okay. Here is the explanation for you. Let us consider two vectors A and B act at the point P, represented by two sides OP and PQ of a triangle inclined at an angle theta. Same thing which I discussed here. And R is the resultant vector represented by the side OQ taken in opposite order. Here POQ is the angle beta is the direction of the resultant vector. Here is the construction, small geometrical mathematical process. The OP has been extended up to M, and QM perpendicular to OP produce OP, extended OP is drawn, right? Now dear student, you see in right angle triangle PQM, you see the triangle PQM here, and here cos theta is equal to B by S, adjacent by hypotenuse which is PM by PQ, and PM is equal to PQ cos theta. Because PQ is the magnitude of vector B, so in place of PQ you can write B, so it is PM is equal to B cos theta. Similarly, sin theta is equal to P by S, perpendicular to hypotenuse, and sin theta is equal to Q1 by PQ. Okay, this side is Q1 by PQ, and Q1 is equal to PQ sin theta, and Q1 is equal to B sin theta. Okay. Again, we see the students in the triangle, in the right angle triangle OQM. Here O, Q and M. So in this right angle triangle, and we can use the Pythagoras theorem. What is Pythagoras theorem? And all of you know. Okay. And the important statement which says that the square of the hypotenuse is equal to sum of the squares of other two sides. Here OQ square is equal to QM square plus OM square, and we will find out OQ. Here OQ means is the magnitude of the resultant vector which is R. QM is equal to B sin theta, already have got. PM is equal to B cos theta, and we have to find out OM. And here OM, and again OP is equal to A, and OM is equal to OP plus PM, which is OM is equal to A plus B cos theta. So you can use this value in equation 3. OQ square is equal to QM square plus OM square, and R square is equal to V sin theta whole square plus A plus B cos theta whole square. So R square is equal to V sin theta whole square plus A plus B cos theta whole square. So we have to expand R square plus B square sin square theta. Here you have to apply A plus B cos theta whole square, right? A square plus B square cos square theta plus 2AB cos theta. Then you have to arrange. Here A square, you see B square sin square theta plus B square cos square theta. Let us arrange here. A square plus B square sin square theta plus B square cos square theta plus 2AB. After arrangement, and you see here, and here B square in the two terms, and there is a common factor B square. We can take the common factor. After taking the common factor, we can write R square is equal to A square plus B square whole into sin square theta plus cos square theta plus 2AB cos theta. Okay. And here you know the formula of sin square theta plus cos square theta is 1. So now you can in place of sin square theta plus cos square theta you can write 1. So resulting expression will be R square is equal to A square plus B square plus 2AB cos theta. Okay. And R is equal to square root of A square plus B square plus 2AB cos theta. and this is the magnitude of the resultant vector R of the two vectors A and B. Right? Now we have to find out the direction of the resultant vector. Okay, you see here, now in the right angle triangle OQ1 and beta is the direction of the angle of the direction of the resultant vector, the angle beta is the direction of the resultant vector, so you can write tan beta, and tan beta is equal to P by V, and here P means Q1 and this means 1. So tan beta is equal to Q1 by 1, tan beta is equal to V sin theta divided by A plus B cos theta, and beta we can write beta equal to tan inverse of B sin theta divided by A plus B cos theta, and this is the resulting expression formula. We can find out the direction of the resultant vector. Thus, we got the two vectors acting by the two sides of a triangle, how to find out the resultant vector R, and R is equal to square root of A square plus B square plus 2B cos theta, and direction of the resultant vector tan beta is equal to V sin theta by A plus B cos theta. Right? So here is another special case. You have to find the most vital point I am going to discuss. There are three special cases because the vectors has direction. Because of the direction, we have to find out the nature of the magnitude and direction of the resultant vector. When the two vectors A and B act in the same order, here theta is equal to 0 degree and cos 0 degree is equal to 1. So we can get R is equal to square root of A square plus B square plus 2 cos theta. In place of cos theta, you can write the value of 1. So we shall get R is equal to A square root of A square plus B square plus 2B. And you know formula of A square plus B square plus 2, which is A plus B whole square. So we can write it will be R is equal to square root of A plus B whole square and R is equal to A plus B. Thus, the two vectors act in the same order. The resultant vector is the sum of the magnitude of the two given vectors. Right? So if suppose a vector A, you can write a vector. Suppose A is a vector whose magnitude is 20 Newton and B is a vector whose magnitude is 5 Newton. So what is the magnitude of the resultant vector is A plus B, which is 20 plus 5, 25 Newton. So in this how you can find out the magnitude of the resultant vector just by adding them, their magnitude. Again we will find out the direction of the resultant vector. We have cos theta, cos 0 degree is equal to 1, sin 0 degree equal to 0. So tan beta equal to V sin theta by A plus B cos theta. You have to use the same expression for finding the direction of the angle. By putting the values, we shall get tan beta is equal to B into 0 plus A plus B into 1, which is tan beta is equal to 0, and tan beta is equal to tan 0 degree because the tan 0 degree equal to 0. So in place of 0, we can write tan 0 degree, and here we can cancel tan we can cancel. After cancellation, we shall get beta is equal to 0 degree, and this is the direction of the resultant vector. So when the two vectors act in the same direction, so the magnitude of the resultant vector is equal to sum of the magnitude of the two vectors, and the direction is the same direction. Okay, and the resultant vector directed in the same direction as the given vector, and resultant vector act in the same direction. Right? This is the case 1. Another case, second case, when the two vectors act in opposite order, the angle between them is theta, which is 180 degrees. So cos 180 is minus 1. By putting the value, we shall get R is equal to square root of A square plus B square plus 2AB whole into minus 1, and R is equal to square root of A square plus B square minus 2AB, which is A minus B whole square, and the value will be R is equal to A minus B. Thus, the resultant vector can be determined by finding the difference of the magnitude of the given vector. Now let's see the direction of the resultant vector. Theta equal to 180, cos 180 is minus 1, sin 180 is 0, tan beta is equal to sin theta by A plus B cos theta. So by putting the value, we shall get tan beta is equal to 0 degree, and which is tan 0 degree, and after cancellation we shall get beta is equal to 0 degree. Thus, this is the direction of the resultant vectors. So when the two vectors act in opposite direction, magnitude of the resultant vector is equal to difference of magnitude of two given vectors and the resultant vector directed in the direction of the given value. So third important case, when the two vectors act at right angle, then theta must be 90 degree and cos 90 what? 0, and r is equal to square root of a square plus b square plus 2ab, and it will be r is equal to a square plus b square plus 2ab into multiplied 0, and the value of r will be square root of a square plus b square. Thus, when the two vectors act at right angle, then the magnitude of the resultant vector is equal to square root of the sum of the squares of the two given vector. Look at the diagram here. And the direction of the resultant vector will be for theta is equal to 90 degree, cos 90 0, sin 91, tan beta is equal to v sin theta by a plus b cos theta. By putting the value, we shall get tan beta is equal to b in multiplied 1 by a plus b into 0, and tan beta is equal to b by a, and beta is equal to tan inverse. So b by a is the expression to find the direction of the resultant vector. Thus, we got when the two vectors act at right angle, then the magnitude of the resultant vector is the sum of the square root of the magnitude of two vectors, and the direction of the resultant vector depends upon their relative magnitude. Right? And here an important problem I am going to discuss with the most vital problem. So look at the problem here. Two forces 5 Newton and 20 Newton act an angle 120 degree between them. Find the resultant force in magnitude and direction. One of the vital problem. Let's see here. According to triangular vector addition, using the formula, force is equal to resultant force is equal to square root of f1 square plus f2 square plus 2f1 cos theta. Here f1 given 5 Newton, f2 given 20 Newton, and theta is equal to 120 degree. By putting the value, we shall get, and cos 180 and cos 120 degree, because angle theta is equal to 120. So cos 120 is minus 1 by 2, sin 120 is root 3 by 2. We shall get the magnitude of the force is equal to 5 plus square plus 20 square plus 2 multiplied 5 multiplied 20 multiplied minus 1 by 2. And here we can cancel, 2 can be cancelled, and after cancellation we shall get 5 plus square 25 plus 20 square 400 plus and minus 100. So we shall get force is equal to square root of 25 plus 400 minus 100, which is square root of 325. By finding the square root, we shall get 18.027, and with the approximate value 18.03 Newton is the magnitude of the resultant force. Right, note it down, and again we find out the direction of the resultant vector. When the two vectors act at 120 degree, and here you have to put the value tan beta is equal to 20 multiplied root 3 by 2 divided by 5 plus 20 into minus 1 by 2. So you can cancel here, it will be, and here you can cancel. After cancellation get 10 root 3 divided by 5 minus 10, and tan beta is equal to 10 root 3 divided by minus 5. Once again we can cancel here. After cancellation get, it will be tan beta is equal to minus 2 root 3, and the value of root 3 is 1.732, and if we multiply we shall get tan beta is equal to minus 3.464, and tan beta is equal to minus 3.464. If we multiply minus 1 on both sides, we shall get minus tan beta. This plus tan beta will be minus tan beta, and here minus 3.464, it will be plus 3.464. And the student, you know minus tan theta minus tan beta is equal to tan 180 minus beta. This is one of the trigonometric formula which you have already studied in class 11 mathematics. And note it down. It will be 3.464, and the value of 3.464 is also the value of tan 74 degree 37 minute using trigonometric table you can determine. Thus you get tan 180 minus beta is equal to tan 74 degree 37 minute, and we can cancel tan on both sides. After cancellation you shall get 180 minus beta is equal to 74 degree 37 minute, and beta is equal to 180 degree minus 74 degree 37 minute, and we shall get 105 degree 23 minute is the direction of the resultant vector. Let me clear you with the help of a stupid diagram here. Suppose this is the one vector whose magnitude is 1 force, whose magnitude is 5 Newton, and another force whose magnitude is how much? 20 Newton. And angle between them is 120 degree. And here the direction of the resultant vector, see, with the resultant vector, okay, and it makes 105 degree 23 minute. This is how you can generalize the directional nature through the diagram and figure. So, dear students, we discuss a vital concept of you, and here is an assignment for you. And also you can prove straight and true parallel law of vector addition, and there are two similar kind of problem, vital problem. Okay, I must be thankful to you for your interest and eagerness for the class, and we shall discuss more and more problem based on the concept. Okay, next we have to discuss what is the cross product and dot product of vectors, which is the important concept of your vector chapter and most vital in various applications.